Okay, we are on our final lesson of Chapter 9. This is Lesson 6 on areas of composite figures. A composite figure is made of two or more two-dimensional figures. So if we think about our two-dimensional figures, we know it's a figure that has two dimensions. So an example could be a square. Its dimension is a side and a side. Another example of a two-dimensional figure would be a rectangle, which has a length and a width. Those are its two dimensions. We've studied parallelograms, and we know we call the dimensions the base and the height. And finally, we looked at trapezoids. And we have actually three dimensions for the formula. We have the base 1, the base 2, and the height. So we're going to recall those formulas when we apply it to area of composite figures. So let's look at our first composite figure. If I looked at this shape here, it's called composite because I can split it into two separate shapes. So this imaginary dotted line is splitting our shape into two rectangles. So what I would do is I would find the area of one rectangle and then the area of the other rectangle and simply add those together. So let's look at the area of the smaller rectangle. I apply my formula. I know area is length times width. So on this smaller section here, length is 7, width is 3. And the area equals 21 centimeters squared. So just this part of the whole entire thing is 21 centimeters squared. Then I look at the bigger one, the bigger rectangle. The area is 6 times 9 because the length is 6, the width is 9, which is 54 centimeters squared. So this part of it is 54 centimeters squared. Now all I do is I find the sum of the two rectangles. So I add the 21 and I add the 54, and together they are 75 centimeters squared. So the entire figure is 75 centimeters squared. All right, if we look at the next one, this is actually a trapezoid, but we're going to take our trapezoid and split it into two separate figures. And you can see here the imaginary line splits right here. And from here to here, it's actually 5 inches. Okay, how do I know that? Well, I know it because these little tick marks here tell me if this side's 5 inches, this tick mark shows me, well, these two are equal. And this one says this must be 5 inches, that must be 5 inches. So actually that's a square. So let's find the area of the square first. And we call the dimensions of the squares the sides. So we would multiply the side by the side. So the area of the square would be 5 times 5, which is 25 inches squared. All right, the other part of that figure has been separated by the imaginary line, and that shape is a triangle. So I have to recall the area of a triangle formula, which is, if I recall, it's half the base times the height. Another way to say that is the base times the height divided by 2. Okay, so I need to figure out my dimensions on that triangle before I can do anything. So if it's 5 inches from here to here, and it's 7 inches all the way across, what's left in that small spot? That must be 2 inches from here to here. So sometimes you just have to figure it out by reasoning. Okay. Now I have my base, which is 2. I have to find my height, which is the imaginary line because it goes perpendicular. And again, I have to kind of reason this out. If this is a square and this side's 5, then this side must also be 5. So the height of that rectangle, I'm sorry, of the triangle is 5. Now I can apply my formula. The area equals 2 times 5, which is 10, and 10 divided by 2 is 5, and it's inches squared. So now the sum of those two figures, put them together. The square was 25 inches squared. The triangle is 5 inches squared. I put that together and I get 30 inches squared for that composite figure. Remember, composite is two-dimensional figures put together. All right, now I am going to look at this shape. It overlaps. So it looks like I have a square and a rectangle, okay? But I'm only going to count this outlined part. I can't count this all over again. So we have to think about what we have to do with this one. All right, I know the square is side times side, and I see the square right here. This side's 12, this side's 12, this side must be 12, and that side must be 12. So 12 times 12 is 144 centimeters squared. Now I'm going to look at the rectangle shape. I could see that this side's 15, the length is 15, the width is 12. So 15 times 12 is 180 centimeters squared. So I have both the rectangle and the square together, but I actually need to take this center part out because I've already counted it. So this is where, again, I apply reasoning. I have to figure out what those dimensions are of the overlapping area. So let's see. If this side is 12 and this side is 12, this looks like it's about halfway here. So this side must be 6. And this up here, I have to erase some of this so I can see these numbers. Okay, so I'm looking for this. So this side must be 6. This side must be 6. Now I have to find the top and the bottom of that square. And it looks like if this is 8 here, and this whole thing is 15, I have to figure out what 15 minus 8 is. And 15 minus 8 is 7. So it looks like the square has dimensions, or it's not a square, it's actually a rectangle, has dimensions of length of 7, width of 6. So the overlapping area is 7 times 6, which is 42 centimeters squared. Okay, I actually forgot to find the sum of these two areas here. So if I added 144 plus 180, I get 324 centimeters squared. So I have the sum of both figures. I have the overlapping part. Now I want to remove the overlapping part. So I need to subtract the overlapping part from 324. So 324 minus 42 is 282. So the area of the figure is 282 square centimeters. All right, come back with any questions you might have. Thank you.